Hey, this is Math 7, Unit 6, Lesson 11, using equations to solve problems. And so in some of these today, we're going to use some diagrams, tape diagrams, sometimes equations, and sometimes just some logic and reasoning to solve some various problems here. So first of all, we have this tape diagram here, and it wants us to write a story that could be represented by this tape diagram. And so a few things we can point out here. We know that we're going to have something with a total of 24, whatever we decide to call that 24, pencils, cupcakes, whatever. We recognize that that 24 is being broken up into three groups. We have group 1, group 2, and group 3. And that within each of those groups we have some number, and then we're adding to it 2 more, whatever that's going to be. So if I had to tell a story, I can make up a story something like John has 24 pencils. Okay, so I could say John has 24 pencils right here. Great. And he takes those 24 pencils and he gives some pencils, we can call the sum the A, he gives some pencils to each of his 3 friends, friend 1, friend 2, and friend 3, right? Here's our friend 1, 2, and 3. He then gives 2 more pencils to each person, and that becomes our story, right? So there's 24 pencils here, and then he gives some to 3 friends, and then he gives each friend 2 more. And that's a way you could kind of have a story about that there. As an equation, that would look something along the lines of he gives each person some pencils plus 2 more, and because there are 3 friends, that's a times 3, and in total we know that he started with 24. And so that's what that could look like in terms of an equation to represent that tape diagram there. We could also distribute that, and it could also be 3a plus 6 equals 24, and that would also be another equation that would be acceptable for what we see in this tape diagram. For this next part, it's called At the Fair. It says Tyler's making invitations to the fair, and he's already made some, right? That sum is going to be what he's made so far. He wants to finish the rest within a week. He's trying to spread out the remaining work to make the same number of invitations each day. Tyler draws a diagram to represent the situation. Okay, so we can see here he's looking like he's going to make 122 invitations. That's what he's going to make there. We recognize the 66 is probably the sum that he's already made. That's probably what that 66 represents here. And then because it's a week, we can see we have 1, 2, 3, 4, 5, 6, 7 for each day of the week, and that's going to be his dividing whatever's left into the same number of invitations each day. That's what we have there. So explain how each part of the situation is represented by Tyler's diagram. So how many total invitations is he trying to make? Our total number of invitations is this number here, which is 122. How many has he already made? Well, that is represented here by the sum. That's going to be the 66 part. And how many days he has to finish the invitation is represented by the number of x's, which is going to be here 7 days. That's the 1 week right here. 1, 2, 3, 4, 5, 6, 7. And that's what we have right there. Now in terms of how many invitations Tyler should make each day, which is the next question, how many should he make? What we want to do is we take a look at our illustration. And for our tape diagram, we know that there are 57 total that he needs to make. Okay, sorry, 57, no, 122. Sorry, I was looking at the wrong spot there. He has 122 invitations that he's going to make. We know that he has, so far, he's made 66 of those ones, right? So he's made 66. And that the 66, he's going to make 7 times x every day. So some amount there, 7 times x. So to figure out how many invitations he's going to need to make each day to reach his goal, pull this up here real quick, we'd solve something along these lines. So I'm going to subtract 66 from both sides so that I have 56 equals 7x, and I divide both sides by 7 so that x equals 8. So to make his goal, he's going to have to make 8 invitations for each day in the week in order to have that combined with the original 66 to make 122. So that's what our equation would look like. And again, I already wrote the equation. So again, the equation is 7x plus 66 equals 122. And you can write that any way. It's the same thing, just written the other direction, and that's how we would solve it. So we've actually already solved it there, but again, this is a review of your lesson, so just to make sure you're getting the right idea. Let's look at number 2. Number 2 is a story about Noah and his sister making prize bags for a game at the fair. So making some prize bags, right? Noah's putting 7 pencil erasers in each bag. So let's see, where's that at? Here's our 7, and our 7. Notice here we have prize bags. These are our bags here. His sister's putting in some number of stickers. Some number of stickers. That's probably going to be our X, right? After filling 3 of the bags, 3 bags. Here's bag number 1, bag number 2, bag number 3. They have a total of 57 items. So there's our total there. So in this equation, this tape diagram, what we can see is we can see our total number is 57. That's how many we have altogether. But what that 57 is going to be combined of is we have some number of stickers plus 7 pencils, and we're doing that 1, 2, 3 times. So this is what this one's going to look like. We have 7 pencils and some stickers happening in 3 different bags, and combined we're going to have a total of 57 items there. And that's the idea. It says Noah writes the equation 3 times x plus 7 equals 57 to represent the situation. Do you agree with him? Well, this is some stickers, 7 pencils, 3 groups, which is what we had before, for a total of 57. I would say I would agree with that because this is 3 groups with X number of stickers and 7 pencils, right? This is 3 groups with X, which stands for some stickers, and 7 pencils for a total of 57 items inside of 3 bags. So how many is he putting inside of each bag, or how many stickers? That's our unknown, our X value. So that becomes 3 times X plus 7 equals 57. They're saying basically solve it. Okay, so let's divide both sides by 3. So that X plus 7 equals 57 divided by 3 is 19. We subtract 7 from both sides, so that X equals 12. All right, so let's do X equals 12 right there. And that's how many stickers there are going to be. Okay, so the last 2 use a tape diagram, and now we move to the third one, which does not use a tape diagram. It says that a family of 6 is going to the fair. They have a coupon for $1.50 off each ticket. If they pay $46.50 for all their tickets, how much does a ticket cost without the coupon? So think about this. They're going to have to buy a ticket. That's our ticket amount. We're going to get a discount of $1.50 for each ticket. Now this is a family of, what did they say? 6. So whatever the ticket price minus $1.50, we're going to do that 6 times. Now in total, that family is going to pay $46.50. It would be something along those lines. That's an equation there. I could draw it as a tape diagram as well, but I'm not going to do it for now. Okay. So how much does the ticket cost without the coupon? That's going to be solving for X. So to solve this one here, we can distribute and distribute. So we have 6x minus 9 equals $46.50. 6x, if we add 9 to both sides, is going to equal $55.50. And when we divide both sides by 6, x is going to be equal to $9.25. So a ticket price is $9.25. Then they take $1.50 off each ticket to find out what the ticket's going to cost with the coupon. This is without the coupon, $9.25. All right, next activity is called running around. And so we have Priya, Han, and Elena are members of a running club at school. And let's see what the problems we have today. It says Priya was busy studying this week and ran 7 fewer miles than last week. Okay, so the 7 fewer miles than last week means that she ran, whatever she runs, she ran last week, she ran 7 fewer. Okay, so this week, so she ran 7 fewer than she ran last week. That's what we know so far for Priya. Then it says she ran 9 times as far as Elena ran this week. So if you do 9 times Elena, that tells you how far she ran this week. This week is going to be 9 times Elena, and this week is also going to be, yeah, so there you go. So Elena then only had time to run 4 miles this week. So Elena equals 4. Okay, so working backwards, how much did Priya run last week? If Elena ran 4 this week, and Priya ran this week 9 times as far, then we know she's going to run 9 times 4, which is 36. Okay, so that's this week. This week she ran 36. Elena ran 4 this week. Priya ran 9 times that, which is 36 this week. But when we look at last week, we know that it's x minus 7. So what we want to do is say, well, let's take our this week total and make that equal to x minus 7 to see how much she ran last week. We'll add 7 to both sides, and we end up with 43 miles. So she ran 43 miles last week. She ran 7 less this week, which is going to be 36. And 36 divided by 9 is going to be equal to 4, what Elena ran there. So I work mine out backwards to figure out how far Priya ran. Could you do it a different way? You certainly could. And in section B, it actually gives you a different way there. It says that Elena wrote this equation. She did 1/9 times x minus 7 equals 4. So that's the how far, right, that Elena ran. And to do this, to solve this, you'd multiply this times both sides by 9, right, which is similar to what we did. We did 9 times 4 as well, the same thing. Let's back up over here real quick. We did 9 times 4 to find out Elena's 36. If I was to solve this one here, 1/9 times x minus 7 equals 4, I'd multiply both sides by 9. That's the first thing we did, right? And then we'd say x minus 7 equals 36. And the next thing we did here is we put our 36 and we set it up over on this side of the equation to say 36 equals x minus 7. It's the same step there. Add 7 to both sides, add 7 to both sides, x equals 43. So it's the same idea, very similar method, just a different way of setting it up. Instead of working backwards, it worked with an actual equation there. Number 2, one day last week, 6 teachers joined 5/7 of the members of the running club. So we have 5/7 of the members. So 5/7 of whatever the number of members there are going to be, plus 6 teachers. Priya counted a total of 31 people running that day. So 5/7 of the members plus 6 teachers is going to be 31 people altogether. So how many members does the club have? That's going to be defined by the value of x. So let's subtract 6 from both sides. So we have 5/7 x equals 25. And to solve this, we'll multiply by the reciprocal. Multiply by the reciprocal. So that goes away. And x is going to be equal to, we can reduce 1/5. 5 times 7 is 35. So there are 35 members in the running club. Number 3, Priya and Han had a fundraiser for the running club. They begin with a balance of -80 because of expenses. So we know they have -$80 in their account. In the first hour of the fundraiser, they collect equal donations from 9 parents. So they started with less than -80, and then they're going to add to that donations in equal amounts from 9 parents. So whatever that donation amount is, that's their x value that happened 9 times. That brings their balance to -44. So when you take their beginning and you add to it the new donations times 9, we're going to equal -44. So how much did each parent give? That's our x value. I'm going to do the opposite, plus 80, right? So 9x is going to equal -44 plus 80. To solve this here, the signs are different, so we're going to find the difference. 80 minus 44, like so. We borrow, we end up with 36. And I keep the one with the greater absolute value, which is going to be the positive one, so it's a positive 36. So we have 36, divide by 9, and x is equal to 4. So 4 is the $4 donation given by 9 parents, and that's what they had as part of their fundraiser there. The running club uses the money they raise to pay for a trip to a canyon. All right, they made some money, here we go. At one point during a run in the canyon, the students are at an elevation of 128 feet. So here they are at 128 feet. After descending, that means going down at a rate of 50 feet per minute. So we're going down 50 feet every minute. I'm just going to make that as a 50 times some number of minutes. They reach an elevation of negative 472 feet. So they're going to get to a place where they're going to be negative 472 feet. How long did the descent take? So what's our minute value going to be? So let's subtract 128, subtract 128. Signs are the same, so we find the sum and keep the sign the same. This becomes 7, 2, 10, negative 600. So negative 50 m equals negative 600. Divide both sides by negative 50, divide by negative 50, and m is going to equal 60 divided by 5 is 12, and it's negative divided by negative becomes a positive. So it took 12 minutes to reach, to make the descent, 12 minutes. That's what you end up with right there. Okay, so these are a variety of problems that we're looking at today.